On the solar maximum, Titan's strange icebergs, and a galaxy without any stars. My name's Rob, and this is your Space Fix. In the dying days of 2023, two remarkable events took place close to our star. The first, and perhaps the more spectacular, was a vast solar flare, the most powerful to erupt from the sun in 6 years. Fortunately, its effects on Earth were minor. The flare merely grazed our planet, leaving little more than a vivid aurora in its wake. The second, however, was an event of great technological accomplishment. On December 28th, the Parker Solar Probe completed its 18th close approach to the Sun, passing into the solar corona, touching a point just 5 million miles or 8 million kilometers from the surface of the Sun. No other spacecraft has dared come so close to our star, and none, therefore, has ever given us such a detailed look. That Parker was so close to the Sun when the flare erupted may seem like lucky timing, but in fact the event was not completely unexpected. Parker's latest voyage past the Sun came close to the solar maximum, a point in time when the Sun becomes blemished in spots and violent tempests rage across its surface. The Sun's activity has been rising for the last 4 years as part of a regular ebb and flow in its behaviour. Roughly once every 11 years, this activity reaches a peak, a moment known as the solar maximum. Afterwards, its activity begins to weaken once more, descending towards a minimum some 5 to 6 years later. For reasons still unknown, not all cycles reach the same peak. At times, indeed, the cycle has almost died down completely. Between 1645 and 1715, for example, sunspots became exceptionally rare, and the astronomers of the day reported a weak and barely visible solar corona. Predicting the strength of future cycles is a fool's game. Yet the past cycle was considered a weak one, and the current one seems to be a strong one. Put together, that means the Sun is now more active than it has been in 2 decades. And that is offering modern telescopes and probes the perfect moment to study our star in depth. For those of us who must remain on Earth, perhaps the most exciting opportunity of the year will be the solar eclipse of April 8th. Over a period of 5 hours, the moon will pass directly in front of the Sun, carving a path of darkness over eastern Canada, across the United States and Mexico, and into the western Pacific. As it does, the Sun's outer atmosphere, the corona, will become briefly visible. For those watching, it will appear as a halo of white light surrounding the moon, within which loops of pinkish red will be seen. Though the corona is visible in most total eclipses, that of April will be a rare chance to see the corona at full strength. In many ways, the surface of Titan resembles that of Earth. Lakes and seas are scattered across the faraway moon, fed by rivers flowing through a terrain of mountains and dunes. As on Earth, the presence of liquid has shaped its contours and fueled an ever-changing landscape. Yet the rivers and seas of Titan are filled with methane, not water. Clouds of the stuff which on Earth exists only as a gas float serenely through its skies. From time to time they fall as rain, filling rivers and lakes with an oily liquid. This cycle of evaporation and rainfall is very Earth-like, but methane, it should be remembered, does not always act like water. When the Cassini probe photographed Titan's lakes in the 2010s, it found them to be strangely flat. Few waves were spotted rippling across them, which was odd since we know winds should be blowing across them. At times, features like islands seemed to appear within the lakes, only to have vanished by the time Cassini returned for a second look. Since their discovery, some researchers have wondered if these islands might really be waves. If the seas of Titan are normally mirror flat for whatever reason, then the occasional outbreak of waves could easily be mistaken for a temporary island. A recent study favours a different explanation, however. As well as methane, Titan's atmosphere contains more complex chemicals made of hydrogen, carbon, and nitrogen. These should fall as snow across the moon, creating a thin layer of floating soot in the lakes. Most of that would quickly sink into the methane, but its presence would be enough to prevent large waves from forming. On land, however, the sooty snow would pile up. Over time, that could result in something like icebergs carving off and floating in the lakes. They wouldn't be able to stay afloat for long. The study calculates they would gradually soak up methane and then sink, but they should last long enough to be photographed by a passing spacecraft and so be mistaken for an island. What is a galaxy without its stars? Of course, galaxies contain much more than just their stars. They host gas clouds, black holes, and apparently copious amounts of dark matter. But it is through their stars that they become visible, and thus known to us. In a chance discovery, however, astronomers recently spotted a galaxy that seems to have no stars at all. It was found by sheer accident. The astronomers had mistyped when pointing their telescope, and only realised their error when they later compared results with those obtained by a different telescope. The galaxy seems to contain only hydrogen and dark matter, making it the darkest galaxy ever found. In form, it could resemble the very earliest galaxies, albeit one in which star formation never got started. That may mean it is made of primordial hydrogen, say the discoverers, which would make it the only nearby object of its kind. So what do you think? Are these mysterious islands on Titan waves or icebergs? Will you be watching the solar eclipse on April 8th? And what do you think about this newly discovered galaxy with no stars? I hope you enjoyed episode 1 of Space Fix, a new series of videos that I will be making in collaboration with Alistair Williams, a brilliant writer who shares a passion for all things space related just like us. If you want to read some of Alistair's other articles, then click on the link in the description which will take you to his page, The Quantum Cat. There's plenty to get stuck into over there. Thank you for watching, and I'll see you next time.